Now, with respect to 2D rotation, we already discussed about 2D rotation in module 2, and what we discussed, rotation about an arbitrary point P in space. Here we are going to do the example program with respect to given origin point as well as set fixed point. Usually the rotation function, how we will perform with respect to your arbitrary point P in space, where we translate the object, then we perform rotate, then bring back the particular object to the original position, right? This is the initial position of the particular object. Then we translate to the given origin point, then we'll perform the rotation, then we'll bring back to the original position, right? This is the initial position of the particular object. We'll bring back to the origin point, then we'll perform the rotation, then we'll bring back to the original position of the particular object, right? So this is what we discussed in module 2 about rotation about an arbitrary point P in space, where you have to specify the matrix of initial translation, then rotation, then you have to bring back to your original position. With respect to this, you got this value. Now we'll see one example program. This is the additional program where you have to copy down to your observation, execute, and write down the output. To draw a house and rotate about pivot point. That set pivot point is going to be your origin point or set the particular. So when you are going to draw a house, how many endpoints it contains? See, if you are going to draw a house, here 1, 2, 3, 4, 5, 6, 7, 8, 9. So totally you have 9 endpoints with respect to this house. So x comma y, first endpoint, second endpoint, x comma y, and third, 4, 5, 6, 7, 8, 9. Okay. So write the program for to draw a house and rotate a house. So you are going to draw a house with 9 endpoints, where you are going to specify your x, y value and space, where you are going to write in your homogeneous matrix form, right? So your x value with respect to 9 endpoints, y value with respect to 9 endpoints, where you are going to specify the rotation matrix 3 into 3, 0, 1, 2. Similarly, resultant matrix 0, 1, 2. And here I am going to specify my pivot point values h equal to 100, k equal to 100. I am going to specify the theta, where what is the theta value? I'm going to specify to rotate the particular object. Then the rotation matrix and the object matrix, initial position of the particular object, then resultant is going to be a transformed house based on the theta value what you are going to give, right? So to draw a house with a given value, where you are going to get the resultant matrix, right? And how we are going to rotate the particular house, what is the function you are going to write for rotate? You are going to build the rotation matrix as we discussed with respect to the rotation matrix. This is with respect to counter clockwise, right? Clockwise, the position is going to change. This is with respect to counter clockwise, where you can see position of 0 is cos theta, position of 1 is sin theta, and position of 2 the value. Similarly 1 of 1 is equal to sin theta, 1 of 2 and 1 of 0, 1 of 1 and 1 of 2. Similarly 2 of 0, 2 of 1 and 2 of 2. Okay, here you can see m is equal to minus h into cos theta minus 1 plus k into sin theta. So you can see this value px minus px cos theta plus py sin theta. In that you can take this px common out. So 1 minus cos theta. Here we have written reverse, which means minus px into cos theta minus 1. So that same value will get minus px cos theta minus px into minus 1 is going to be plus px, right? So similarly for n, okay, py cos theta and py minus py cos theta minus px sin theta, right? So specifying your rotation matrix position at 0, 0 cos theta, 0, 1 and minus sin theta, position of 0, 2, the value of m minus h into cos theta minus plus h plus k into sin theta, and rotation matrix with respective position. 1 of 0 is sin theta, 1 of 1 is going to be cos theta, 1 of 2 is going to be n, and 1 of 2 0 and sorry 2 of 0 0, 2 of 1 0, 2 of 2 1. So multiply two matrices. How you are going to perform rotation matrix multiply with your object matrix. Here the object is house, right? We are going to draw a house using line loop, right? So each and every polygon when you are going to draw, the command should start with the begin and end. Here the constant you are going to use gl underscore line underscore loop, where we have 4 endpoints, right? And similarly we are going to draw the endpoints of house, right, where 4 endpoints, here 4 more endpoints. We are going to draw these two using gl underscore line underscore loop, right? And for a house, and you are going to draw using a line loop. Similarly this is for draw a house, and you have to draw the rotated house also. Same for rotated house, and where you are going to display the draw house or rotate and rotated house. And a single screen we are using, for that we have used gl flash function, and your clear screen and with the color white, and you are going to write the new color where you are going to specify the projection matrix and the projection screen coordinate value also using GLU ortho 2D, right? Where you are going to write the main function, where enter the rotation of angle, where you are going to specify the theta value, okay, where theta is equal to theta multiply with 3.17 divided by 180. Why? Because you have to convert the theta value, right? You are going to write either 30 degree or 60 degree. Okay, here what is the pi value? Pi value is equal to 3.17. okay, so to do the theta conversion, you have to write theta is equal to theta multiply by pi by 180, right? So specifying a display mode and specifying your window size, window position, and what is your name of the window, right? And this is going to be your output, where we have specified the theta value is equal to 45 degree. We'll see the execution part. Here I am going to specify theta value is equal to 45 degree. So I will view the output at 45 degree, right? And right, next, that is additional program for 2D rotation, and this is your lab program where you are going to draw a triangle and rotate a triangle about the origin point and a fixed point, where you are going to draw a triangle, rotate a triangle about the origin and fixed point, where given point where you have to specify your x and y value initially, where to rotate as well as rotation angle, and where you are going to specify your float values of translate x as well as y on 0 0, and here the point where you are going to specify rotation as well as fixed point as well as origin point. That point you are going to specify with a point size 10, and you are going to draw a point, and you are going to draw a triangle, right? Triangle with a color RGB, where you are going to specify the color green, and draw a triangle with respective initial position of x comma y, then this A, B and C, where you are going to draw a triangle 3 points A, B and C, right? And display, where you are going to draw a pixel, and in that you are going to specify rotate around the origin as well as fixed point. So initially rotate around the origin point is 0.0, or you can change the value and you can try also, right? Where you can specify the origin point, what is the value of x as well as y, then you can specify rotate around fixed point, and from this particular rotation point to this fixed point, like what is the value you are going to give in a command line for x as well as y. So based on that, it is going to draw a pixel, right? And for drawing the function for translation rotation, right? This is the initial position of the object, then a rotation of the object, then bring back to your original position of the particular object, right? So you are going to write the function gl translate, where you are going to translate with respect to your x as well as y as well as the space points w, right? Where you are going to specify translate object position, rotate object position theta comma x comma y comma, where you are going to specify homogeneous coordinates. When you are going to write, you are going to specify the space, okay? Similarly, you are going to bring back to the original position of the particular object. So post display, if any changes over there in this translation matrix, which will redisplay, and glut swap buffers, where we are going to use two different screen, right? Draw as well as display. So draw and display. So two buffer screen we are going to use. For the double buffer screen, we are using glut swap buffer. Then initialization of your screen, right? Specifying your screen coordinates, right? Then as we discussed in polygon clip, right, where you are going to fill a menu using for polygon clipping. Same here also, for rotation of the particular object, you have to write the menu. What are the menu you are going to write? You are going to write for rotate menu, and you are going to write rotate menu for what? At fixed point and at origin point, and you are going to stop the rotation. For that you have to write the menu. If option is equal to 1, what is the menu is going to function, and option equal to 2, option equal to 3, right? Here is your main glut initialization. Enter the fixed points of x comma y, where you are going to enter those values in the command line, and specifying your display mode, where we have used draw and display double buffered window. So here I am mentioning glut underscore double glut underscore RGB, and no need of using glut underscore depth over here, and specifying your window size, and create and rotate a triangle, that is the your window name, and you are going to initialize your display as well as rotate menu. And here the menu entry we are using, whereas I told you before, like here we can use either keyboard event or mouse event to perform these actions. Here we are going to use the mouse event, where you are going to use the mouse event at glut underscore right button, which will perform the action of rotate around the origin, rotate around the fixed point, stop rotation. Menu will be displayed. You can click on that, where you can use glut underscore right button, glut underscore left button, glut underscore middle button. So all three options you can use. So based on that, your menu you can use, where rotate around the origin, rotate around fixed point, and stop rotation, right? So where you are going to enter the values of x and y, and rotate around origin point, and rotate around the fixed point. What is the value you are going to give for x and y, and you are going to stop the rotation, where it will stop the rotation, at which point it performs the rotation, right? So we'll see the example. Where I'm going to specify the rotation points, right? So here initially with respect to this origin point, so rotate around the origin, it will rotate, and next rotate around fixed point, so it will rotate the specified fixed point, the value of 150 comma 150, and stop rotation, it will stop the rotation, rotate around the fixed point, stop rotation, which will perform the stop rotation. Okay, so stop rotation, where the last moment of the particular triangle done at which point, either fixed point or origin point, there it will stop the rotation, rotate around the origin, right? So stop rotation, and this is the output.